Hello everyone, welcome to our channel. And today we are gonna learn about thermal voltage and what is the importance of thermal voltage and what are the possible equations that we need to remember in order to solve problems in EDC. So this is the first topic that we are going to start from EDC. So what is thermal voltage, or you can also call it as equivalent voltage of temperature, or voltage equivalent of temperature. You can call any of it. So what my thermal voltage state is? Vt is equal to Kt by Q. So what is this K, T, and Q? Many of you would have known this K is Boltzmann constant, and this will be same across anywhere. The value of K will be same. So the value of K is 1.34 into 10 power minus 23 joules. If I am taking Q is charge, and my unit charge will also be same, 1.6 into 10 power minus 19 coulomb. So, and T will be temperature in Kelvin. So I think it is clear up to this one. So here we will substitute these values of K, T, and Q here, and we will make one standard for value for this thermal voltage. So let us assume that T is we will calculate for T at room temperature. So my T will be 300, right? T will be 300 at room temperature, because normally we assume 25 degrees Celsius as room temperature. So it is 75 plus 25. Yeah. So this is the room temperature. So let us first initially calculate the value of K by Q. So here I will take K by Q values. K by Q is equal to, that will be 1.34 into 10 to the power minus 23 by 1.6 into 10 to the power minus 19. And this will give me, and these are all inverse, right? So it will give me 1 by 1.3, 1.6 by 1.34 into 10 to the power minus 19 by 10 to the power minus 23. That gives me 1 by 11,600. So this is K by Q value. So what I will write, Vt is equal to K by Q, that is 1 by 11,600 into T. So simply I can write as T by 11,600. So from this derivation, from this equation, we can draw that Vt is directly proportional to T. We will verify that when I say Vt is directly proportional to T, because K and Q are constant. Whether you may say the value of Vt will only depend upon the temperature only, because even though if you take the material in different temperatures, the values of K and Q will always be same. So this will always be a constant, and Vt will be directly proportional to Q. So we will understand what is the dependency of Vt and T. We have learned that it is directly proportional, and we will try to learn how the graph will be formed. So let us assume here, if I am having Vt, if I am having a greater number of T, then my Vt will value also increase. And similarly, if I am having less T, then my value of Vt will also be less. So what we can write, if I am increasing temperature, then my Vt will also be increased. If I am decreasing the temperature, then the thermal voltage will also decrease. So this is the one derivation that we can draw from Vt and T. So after this it is okay. Now what we will do is, we will calculate the value of Vt at standard temperature. That is, I've told that previously T for T is equal to 300 Kelvin, we will calculate it. So for Vt will be T by 11,600. So what it will be, 300 by 11,600. So and that gives me 3 by 116. So I will get this one as 3 into 116 this is in volts. In order to convert into millivolts, I will multiply with 1000 millivolts. Then my answer will be Vt is equal to 25.86 millivolt. This is frequently asked gate question. This they'll directly ask uh, what is my thermal voltage at room temperature. Then you simply need to write if they are given, if they may not give exactly to 25.86, they may give 26 millivolts or 25 millivolts. Based upon the given options, you need to select this one. So here we calculate the standard room temperature. We can write this one as, this one is approximately at room temperature. Vt is approximately 26 volts. So this you can also, if this option is available, you can simply take this 26 volts in option and you can come here. So let us understand the unit here. What is the unit for thermal voltage? So what we will do is, we know kT by Q is equal to Vt. So kT is equal to Vt into Q. So you know that voltage into charge, that is energy. And the energy is the unit of energy is joule. So if this is the energy of joule, if you are having RHS is equal to energy and that is joule, then this will also be energy, and my unit for this one will also be joule. I think you understood up to this one. So we know that if, let us calculate at 1 volt what will be my kT. So here I will write for kT at 1 volt. kT is equal to 1 into 1.6 into 10 power minus 19. So my answer will be 1.6 into 10 power minus 19 joule. So this is very small, and in all and every time it is very difficult to represent this one. So what I will simply do is, if I will convert this one into electron volt. This is very small, so it is very hard to represent. So what I will do, if you know, if I am having 1 volt is equal to 1000 millivolt, if I am able to represent 1000 millivolts into 1 volt, then that is easy. But if I want to represent 1 millivolt, then I need to represent in 0.0001 volt. So that is sometimes this becomes difficult when you are calculating large number of values. So this is this kT joule, the value in joule also is similar to this. 1 millivolt is equal to 001 volt. They are only 1 001. And now we will convert this one into energy into electron volt. In order to convert energy into electron volt, what I will do, 1 electron volt into 1 volt, and this is, I am taking 1 volt and Q, this 1.6 into 10 power, I am taking this 1.6 into 10 power minus 19 as 1 electron volt, and I am taking Vt as 1 volt and this Q as 1.6 into 10 power minus 19, and this kT will become energy, so that will be 1 electron volt. So what I will do is, I will keep 1 electron volt as it is, this one, and I will simply write 1.6 into 10 power minus 19 into 1 volt. In order to calculate joule, I am telling this one. So 1 electron volt is 1.6 into 10 power minus 19 joule. So if you want 1 joule, then what I will do, I will give 1 electron volt and divided by, I will shift this one to this denominator of 1 electron volt here to LHS side, 1.6 into 10 power minus 19. So this will give me 10 power 19 by 1.6 volt. So 1 joule value is 10 power 19 by 1.6 electron volt. So similarly, let us say, let us calculate for kT at, now we will calculate kT in electron volts. We will convert that into electron volts here. So what we will do is, at T is equal to 300 Kelvin, we will calculate Vt. We know Vt is 26 millivolt. We will calculate kT, and that one if you want to write in volts, then that will be 0.001 0.026 volts. Right? Now I will calculate KT. Then my KT will become KT is Q into VT. And we have taken that unit charge will be 1 electron volt. 1 electron volt into 0.026 volt. Then my KT will be 0.026 electron volt. If I want to convert that into millivolt, then that will be 26 milli electron volt. So this is how if you are given VT, then this is how we will convert that into KT. And I think you understood the thermal voltage concept here. Equivalent this one, that is KT by Q, and we have taken this KT separately, and this K by Q will always be constant. So that is why we are calculating K by Q first, so that while solving thermal voltage, then all you need to do is put the given temperature here, and then calculate it. So this is the relation that we have obtained from the observation that we have drawn here. So that's all. That is all for the thermal voltage. In next video, we will learn about energy gap diagram. Until then, take care. Bye.